Hello and welcome. Today I will be going over how a floppy drive works. So as you can see, this is the floppy drive disassembled. This is the case. This is the top. This is the front. It would go right here like this. Now I will play a video showing a floppy drive in action. Now I will go over how this circuit works. So first of all, it has 4 pins over here which provide power to the entire circuit. These pins also provide some power, but they are connected to the computer. This is the stepper motor. It moves these heads around while they are doing operations on the floppy. These are the read and write heads. They are plugged into the bottom of the circuit, and this is a component that is intended to hold these cables together. Or so I believe. Flipping the circuit, the stepper motor would go under here. It was connected right here. This is a swindle motor. It was located right here. We even have 2 MOSFETs over here. So it was positioned like this. On top of it, this case was placed. And inside this case, around it, was a ring made of magnets. So once we put it over, it would be like this. And it was used for spinning the floppy drive. And it was used to spin the round part of a floppy drive, because it spins. This spindle motor is actually a very ingenious design. Basically, these are the stators, so you would never see such rotation. Only this part with the magnets would rotate. This would stay stationary. Basically, each of these copper coils gets some electricity, and then the magnets get the post from it, and so they spin. It's not a strong spin, but it's a very energy efficient one. So in this reader, both of the heads would move back and forth because they are interconnected into one component. So turning the board around, we have this component labeled KA2822D, which is a 3-phase spindle motor driver. Each phase is 120 degrees. It has digital speed control, current limit, thermal shutdown if it gets too hot, and has TTL, which stands for transistor transistor logic. These over here, as you can see, are 4-pin Hall sensors. They are used to get the motor in position via the Hall effect or via magnetic sensing. As you can see, these are the 2 Hall sensors. For the Hall effect, you would need to read up on that yourself. Over here, these components labeled SW1 and SW2, or this is SW1 actually, have buttons under them, which I presume maybe are used for diagnostics or something, because they are connected to the rest of the circuit. So I presume maybe they're used for diagnostics or detecting whether the floppy disk is open. I'm not sure about that, because you can press them from the bottom, like so. Rotating the board again over to the spot where we have the stepper motor, you have the KA2821D. It's a 2-phase stepper motor controller for this stepper motor over here. It has an on and off function, built-in thermal shutdown if it overheats, and also has transistor to transistor logic. Once we rotate the board again, this is this component with a very long random label. It amplifies read-write signals during read and write operations by the 2 heads. As you can see, this is the component, and if we turn, the read-write heads are really close. This is just the CPU which controls the whole unit. on itself, so it gets the input from these two buttons, shines this LED, sends signals to spin this motor, to also spin this swindle motor, to get signals from the computer via these pins, to read and write data onto the floppy disk. In summary, this floppy disk reader is actually, according to the label, this whole thing uses 5 volts and 0.7 amperes. And 5 volts of direct current, of course. So, in summary, this floppy reader is actually a small computer, judging by its quite large CPU. This is the stepper motor controller. This is the stepper motor controller, which has 2 phases, each 180 degrees. Has an on and off function, built-in thermal shutdown, and transistor to transistor logic. This integrated circuit amplifies the read-write signals from these heads to and from them, so receiving data and writing data. This is the component for controlling this very power effective swindle motor. It also has an on and off function and transistor to transistor logic and thermal shutdown if it overheats. This is the swindle motor. The copper coils are stators, they don't move. Each time they get a charge, this ring with magnets in it spins around it. This is an LED to indicate different signals from the floppy disk reader. These are 2 buttons probably used for servicing. These are the power pins. This is the stepper motor used for moving these read and write heads, which are connected on the bottom of the circuit. And this is a component to keep them straight, so that the cables don't move. What I find impressive here is how little volts this entire thing uses, and also this swindle motor, which I have never seen before. It's also very efficient, uses around 1 volt, and the fact that this floppy reader has some kind of service mode. Thanks for watching, tell me if you like this kind of videos, and see you in the next one.